Okay, another L'Hopital's rule example. This one I think is fun. We have, as we plug in, what we have here is x going to 0. Natural log of 0 is undefined. As you get close to 0, the natural log gets closer and closer to negative infinity. So this is a 0 to the infinity indeterminate form. That is an indeterminate form, but it's not a 0 over 0 or an infinity over infinity, which is what we need to be able to use L'Hopital's rule. So what do? We don't have the right form, and so again, like in the previous example, what we need to do is some algebra to make this into the right form. It has to be a 0 over 0 or an infinity over infinity. So what we're going to do is a little trick that we can do every time we have a 0 times infinity indeterminate form. We're going to take one of the factors and rewrite it in the denominator. So x is the same as 1 over x. It's a weird way to think about it, but it's true. X is the same as 1 over x. So when we write it that way, what happens is we end up with, as x goes to 0, the numerator, natural log of x, is going to negative infinity. And the denominator, 1 over x, as x gets small, also goes to infinity. So we have an infinity over infinity indeterminate form now. So now we can use L'Hopital's rule. That's the trick we need to do every time we have this 0 times infinity case. We put one of the things on the bottom, and we end up with a infinity over infinity indeterminate form or a 0 over 0 indeterminate form. So that's great. Now we can use L'Hopital's rule. So our L'Hopital's rule step, our limit is going to be the same as the limit of the derivative of the numerator, derivative of natural log is 1 over x, over the derivative of the denominator. And the derivative of 1 over x is negative 1 over x squared. So not a L'Hopital's rule step now, just algebra. Let's fix this up. 1 over x times negative x squared over 1. That is multiplying by the reciprocal. That is going to be the limit as x goes to 0 of negative x, with the x's canceling. So as x goes to 0, negative x goes to 0. And that's our answer. We used L'Hopital's rule once, and we got, after a little bit of simplification algebraically, we found that the limit is equal to 0. So that's great. That's a common trick to take one of the factors in a 0 times infinity and rewrite it so that we can have a 0 over 0 or an infinity over infinity.